I'm Ben Cohn from benkphysics.com. Hope you're doing well. I'm doing great this morning. All right, so compute the volume of a solid that is obtained by rotating the region about the indicated axis. Okay, we can do this. Not too hard. So I'm going to do about the line y equals 4. It's all kind of the same concept, but I think the y equals 4 kind of gets the most interesting. So we're going to do something kind of like this. Start by drawing the area so we can help visualize what's going on. So we got y equals e to the negative x, which looks probably something kind of like that, where this right here is 1, because e to the 0 is 1. Even e to the negative 0 is still 1. And then as x gets bigger, it's going to go towards 0 but not reach it. That little bump right there, not supposed to be there. Keep getting closer to 0. We then have x equals ln of 8. So natural log of 8, e is like, I don't know, 2.7-ish. So maybe a little bit bigger than 2. So we'll say this is 2 right there, maybe natural log of 8. Sounds good, okay. And then this is the y equals 0 axis, x equals 0. So we have this region right here. That'll be bounded. And we're going to rotate about y equals 4. So we have a whole bunch of up here. It goes to 4, then it keeps going more, and we get eventually up to 8. And so if this is like 7, then we have something that looks identical as this one, but rotate up there. So our final shape will look something kind of like this. Hoop, hoop. And then it'll be hollow on the inside. And we're supposed to find the volume of this solid. So the region we have is on the outside, so we're actually looking at something kind of like this. And there's different ways to figure out volume of solid. We're going to use the disk method. Well, I think it's kind of called the washer method, but I call it the disk. I call it the disk method. Specifically, I call it the disk minus disk, because we kind of calculate like a little disk here, and then we subtract out another disk in the middle, which I guess is kind of a washer, but I like to think of it as the disk minus disk method. That way it's easier for me to visualize. Okay, start doing the maths. Math, go to red, green. Okay, so the equation we're going to use is something along the lines of, we'll start with x, we'll end with an x, we'll go this way, and each of these is going to be a disk. So the disk will be pi r squared, because that's the radius of a circle, and then the thickness will be delta x. But we're going to do a big one minus a small one, so it's going to be pi r big squared minus pi r small squared, where the big one is just going to be 4. That's going to be r big, and then r small will just be this guy right there. So we're going to write out some equations. Let's do r big equals 4, and then r small we'll say equals, let's see, it'll be 4 minus this, which is e to the negative x. So we'll have 4 minus e to the negative x. And that kind of makes sense too, because then the inner radius, as x goes to infinity, will get closer and closer to 4, because you'll have 4 minus e to the negative infinity, which is the same as 4 minus 0, which is pretty much the same as 4. Okay, plugging things in. So we have, running out of real estate here. Let's see. It's maybe up here. I'll erase this top portion. Erase. Click. Pen. Ooh, this pen. So we'll do pi. I know it's kind of small. It's okay. We'll get over it. Integral, because I just factored out the pi. 4 squared minus quantity 4 minus e to the negative x quantity squared dx. Okay, we can do this. So we'll then have pi integral 16 minus, and this will be, so let's see, we have to FOIL this. It'll be 16 minus 2e to the negative x plus e to the negative 2x. E to the negative 2x is just e to the negative x squared. Dx, let's see here, change colors so that we can cancel effectively. So this will be negative plus, and this will be a negative, distribute. The 16s will go away, and we are left with, let's see here, trying to preserve real estate. I wonder if there's a click. Okay, there we go. Click, clack. Ah, I don't like the freehand. Darn you, freehand. Ooh, orange. Pi integral 2e to the negative x minus e to the negative. Ah, there we go. There we go. 2e to the 2x. Yes. And then we'll go from x initial to x final. But we know that x initial will just be 0, and x final will be natural log of 8. Free up some more real estate. There we go. Go, 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 go. Squish, 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 squish. And there we go. Yep, okay. So now we'll do pi. So the integral of 2e to the x will be 2e to the negative x all over negative 1 minus e to the negative 2x all over negative 2. The integral of e to the negative 2x is e to the negative 2x divided by negative 2. And if you want to figure out how to do that, that's through substitution. Okay, now we have our limits of integration. I'll just still leave those x initial and x final because that's fine. I'm good with that. We write things maybe one more time to get something a little bit clearer in life. And we have e to the negative 2x over 2 minus 2e to the negative x. Okay? And we're evaluating it from 0 to natural log of 8. Boom, boom. Is that correct? Mostly correct. I'm happy with that. Happy with that? Happy with that. Okay? So now we need to actually plug in our limits of integration and get some sort of answer out. Free up more real estate. Hop, hop, hop. I feel so bad losing things that I wrote. I'm like, I worked so hard to write that. So hard. Okay. So now we have pi. I'm going to do this on the side, kind of a sidebar. E to the negative 2 natural log of 8 equals e to the natural log of 8 to the negative 2. 8 squared is 64, and the negative kind of flips it. So I have e natural log of 1 over 64, which is just 1 over 64. So what we're going to have, and then e to the negative x is e to the natural log of 1 over 8, because the negative just flips it, which will be 1 over 8. So we will have, first one, e to the negative 1 over 64, but it'll be 1 over 28 because we also have this 2 involved, minus 2 times 1 over 8, which will just become 1 over 4, minus, and I'll make another big thing right there, and this will be 0. So it'll be pi, there we go, pi times e to the 0, which is 1, but 1 divided by 2 will be 1/2, minus 2 times e to the 0, which will be 1, which will then, 1 times 2 is 2. Okay? I'm going to simplify things just a little bit because I can see this is going to be negative. I can see that's going to be negative 2. So I'm going to switch things around, reverse it if you will. Ooh, green, green. So we'll have pi times 3/2 minus, because this is negative 3/2 times negative pi, positive 3/2. And this will be quantity 1/4, 2 divided by 8, minus 1 over 128. And we can simplify that a little bit more, but yeah, you can do that with your you can put that in the calculator. You can combine terms, you can do that part on your own. So to backtrack, there's a lot of stuff that went on there. What happened here? Oh, this is actually the correct answer. Final answer right there. Yes. So to backtrack, the way this is done for about y equals 4, you first draw the area, the region you're going to look at. You visualize how it's going to rotate around. You draw yourself a little diagram. Oops, something kind of like, no, that's backwards. Goes from big to small. Yep. Maybe it does. So something like this will be the interior dimension. And then the area that you're actually looking for on this is this up here and that down there, rotated about. And so we use the disk minus disk method. It's easiest to go from left to right here. So we'll use dx, starting from 0, going to natural log of 8. And so we use pi r squared, and we integrate from left to right. And after we do the integrals, plug in all the numbers, do some natural logs, get a final answer. And that final answer is something along this lines. Hope you enjoyed it. Thank you much. See you next time.